buckaroos and buckarettes, it's good to be back with you. Today I'd like to tell you how to solve systems of nonlinear equations using the Fsolve function in Matlab. Now this all sounds pretty intense. It's really not. So let's start with, what's a system of nonlinear equations? Well, a system is just the name that mathematicians give a group of equations that share variables. So this is a system of two equations. Y equals cosine x and y equals x squared minus 1. That's a system. They share the variables x and y. Here's a system of three equations. There they are right there, and they share the variables x, y, and z. So their mathematicians call them a system. That's all that means. So what's nonlinear mean? Well, nonlinear means if you draw a picture of it, you don't get a straight line. Well, obviously neither one of those gives you straight lines. It's a little harder to tell in 3 dimensions. Well, the three-dimensional version of a straight line is a plane. Well, let's see. That's a plane. That's clearly not. That looks kind of like a bowl. And that's a sine function that only goes in one direction. So that's obviously not a system of linear equations either. Now, just to be sure, when you have a system of equations, if any one of them is nonlinear, you have a system of nonlinear equations. If you have 100 linear equations and one nonlinear equation, you've got a system of 101 equations that you have to solve nonlinearly. So, how do you do that? Well, there's a bunch of algorithms that do it, and without getting into the details of how the algorithms work, there's a couple of commands in Matlab that are pretty dang useful. Now, first, there's one called F0, which solves a single equation, linear or not, and there's a function called Fsolve, F-S-O-L-V-E, there, that solves systems of nonlinear equations. So what I want to do now is I want to tell you a little more about these, and then let's go to my computer and we'll solve these using Matlab. Now, before we can go any further, let's make sure we know what solving a system of equations means. Well, in this case, it means finding a value of x so that y is the same for both of them. Okay? So if I find an x makes that y equal to that y, I've solved the equation, or the system of equations. Now, what that means graphically is if I plot this function and that function on the same axes, where they cross, that's the solution. So where they cross, I found a value of x so that y is the same for both equations. That's all that means. Here, I'm trying to find three values of x, y, and z, three variable values that make all those equations true. So in practice, what that means is I've now got three surfaces that all have to cross at a single point, or at least one point. So when you have systems of nonlinear equations, it's not always clear that they will all cross at one point. If they don't cross at one point, the system doesn't have a solution. All I would have to do here to make this have no solution is just subtract some big number from that first equation. That would lower this to the point that it never crossed that function. Just because you can write several equations as a system doesn't mean the functions cross anywhere, and therefore doesn't mean they have a solution, or at least not a real one. Well, I've done my homework. These two both have solutions, real solutions, and they're pretty easy to find. So let's go to Fsolve, but one thing we got to do first, this isn't the format Matlab is looking for. It's looking for two specific differences from these. Number one, Matlab and most other codes assume that your system of equations are written in the form f of x equals 0. So you got a bunch of equations where something on the left-hand side equals a 0 on the right-hand side. So let's fix that first. And I'm just going to subtract y from both sides here and slightly rearrange. So I get, oops, hang on, it's not going to work. Give me just a second here. Okay, so I've got functions equal 0. Okay, that's the first step. Now, the second step, if I'm going to use two different variables, they need two different names. Well, how about x and y? That's what we would normally write down. There's 26 letters in the alphabet. If I have more than 26 variables, what do I do? Well, mathematics needs to be more general than that, and Matlab is more general than that. So it expects your variables to be in a vector, and I'm going to call, in the sample here we're going to do in a minute, I'm going to call that vector x. And so I'm going to have x1 is going to be x, x2 is going to be y, and when we get that far, x3 is going to be z. So how do I tell MATLAB what these equations are. Right here, pretty intuitive. Right here, still pretty intuitive. I'm going to write something down here that's a lot less intuitive, but MATLAB knows what it is. So here's what I'm going to get. And I'm going to write this down with lots of parentheses and MATLAB lingo here. Okay, so that's what it's going to look like, right? Cosine of x, which is now x1 because x is now an element of a vector of variables, and that sub 1 means that's just the first element in that vector. The second element of that vector is my second variable, x2. So there's the 2. So x1 is there, x2 is right there. There's the cosine, so we're okay with that. Here's x1 squared minus 1 minus y. There it is. So this is how I'm going to write this out for MATLAB. While I'm at it here, let me fix this as well. Okay, a lot less intuitive, but now MATLAB knows what to make of it. So with this in hand, let's go to my computer, fire up MATLAB, and let's use Fsolve to find the solutions to these. Alright, so here we are in MATLAB. I'm showing you the command window here, the workspace window there, and the command history there. There's some other windows, but I don't have them on the screen here. I'm trying to keep the letters on the screen as big as I can so you can see them. The other one's the current folder window, and we don't need that right now. So before we use Fsolve to find the solutions to these equations, it would be nice to see what they look like. Since I have a 2D and a 3D problem, we can plot both of them. So let's do that. Let's start with the 2D problem, and let's maybe make a list of x's that goes from -2 to 2 in steps of 1 over 100, 0.01, putting the semicolon at the end there. Here's what happens if I don't. I get all the numbers to the screen. Well, I don't want that. That's a pain in the neck. So if I put a semicolon at the end, it suppresses the echo, is what they call that, but it doesn't write all the results to the screen. Now from -2 to 2 in steps of 0.01, you'd think there'd be 400 numbers in there. Well, there's 401. You can see it right there. There's 401 numbers in that list. And the reason is there's a 0 in there. Remember, you're starting from 0, so that's that extra number. So let's just fill out the two equations. There's cosine x, and y2 I'll call x squared minus 1. Suppress the echo. Now this is not going to work. This is going to throw an error, and there it is. And the reason it did that is because that x squared right there, I'm trying to multiply x by itself. That's basically a vector multiplication. Well, there's a couple different ways to multiply vectors, and MATLAB will do all of them, but it needs to know which one you want, and I didn't tell it. So there's the error. Well, I want to multiply the vectors element by element, and in MATLAB lingo, or MATLAB syntax, you put a dot in there, and that tells MATLAB right there, I want you to multiply x by itself, element by element. So there it is, and there I've got 401 numbers again. So let's clear that maybe and make a plot. Well, I can plot as many curves on the same axes as I want just by stacking them in here inside the plot command. There it is. Okay, that's a little rough, and I really don't like those colors. I'm a primary color kind of guy. So let's try something else here. I'm going to make this one red, and you do that by putting the letter R inside those single quotes. And I'm going to make this one blue. This is bright red and bright blue, primary colors, I guess. And these are just two of the many plot options I can put in there. If you look in the help files for the plot command, there's all kinds of things you can do in there. Well, the other thing I want to put in here is grid, so let's do that. Put this down here where you can see it. And there's the grid, got a grid on there, so that's pretty handy. If I want to make these lines wider, I can go to line width there, and I can make that a 2. And let's maybe make that a 2 as well, so it's easy for you guys to see. There, that's better. Uncheck the arrow there. Now, if I cruise over here and I just hover for a second, See all this stuff that just popped up? Well, I can zoom in by clicking on the, I guess it's a magnifying glass, and I can zoom in as close as I want. Now remember, I might be between points here. The fact that there's a line there doesn't mean I actually calculated any data there. But by looking at this, looks like the right answer is 1.76 something. What's that, 765 maybe? Something along those lines. So I know about where that one is. I can right click here and say restore view. Let's just do the same thing over here. This is symmetric, so it better be minus 1.1765, I guess. Yeah, there's 1765 right there. So now I know what the right answers are. I don't need that anymore. Let's go ahead and figure out how to put this into Fsolve. Well, I'm going to use something called an anonymous function. What anonymous function does is it lets me work with actual functions rather than lists of numbers. So I'm going to write an anonymous function for cosine x and x squared minus 1, but using that format I had on the board. Matlab always wants to see vectors, and so it's going to see a vector of variables, but it also wants to see a vector of equations. So I'm going to open a vector right there. There's that left bracket, and I'm going to write cosine x1 minus x2, okay, which is what I had on the board. That's the first equation. And the second one here's my second equation. Just hit return, and there it is. Now see it over here in the workspace? It actually shows as a function, and I can evaluate this function. Okay, you can see over here I messed up a little bit in the command history. I typed in something incorrectly. But I can evaluate fn at any value of x1 and x2 I want. And here's how not to do it. You can see I did it. Check the command history. Here's how I did it a second ago, and I've edited that out. I gave it x and y, which is what I thought it wanted. But wait a minute. It's not expecting x and y. It's expecting a vector. So rather than that, let's give it a vector. There it is. That's a vector of x's. Oh, and now it works. Now this is the value of those two functions over there evaluated when x equals 1 and y equals 1. Well, the way I wrote the equations out, both of those equations should equal 0. So what I'm trying to find is variables there that make this solution 0. Well, I don't have that now, but let's use Fsolve to do that. So I say fn, okay, because that's the name of my anonymous function I've defined, and I'll just give it a starting point. Now, Fsolve is like a lot of other algorithms. It needs a starting point. It doesn't have to be a very good one, but it has to have one. And if I'm really lucky here, if I've done everything right, it doesn't have anything to do with luck, but if I've done everything right, I'll get 1.1765, I guess. And there it is, 1.1765. And there's the y value. I don't need it, but there's the y value. And all this stuff here just says, okay, I've solved it. Here's all the information I want to tell you about how I solved it, and there's the answer. Now, how do I get the other root? Well, you just give it a different starting point. I'll make x minus 1 now, and there's the other answer. So that's how you do Fsolve for 2 variables. Fsolve for 3 variables, just more of the same thing. Let's clear everything out here, and let's make a plot of what that system of 3 equations looks like. Now I'm going to have to do this in 3 dimensions. So I'm going to use the same x range and use an identical y range, and I'm going to draw this in 3 dimensions in what's called a surface plot. So I'm going to start with the same range there. Now I'm using capital X here. I'm using capital X for a reason. I'll tell you what that is in a second. Okay, so there's x and y. I have a list of x's and a list of y's just like before. But here's the problem. In order to do a surface, I don't need vectors of x and y. I actually need a grid of x and y's. It's often called a mesh. Well, I could write some kind of nested loop thingy to do that for me, or you got to figure MATLAB's got to have some command like that, and it does. It's called mesh grid. So I'm going to write this out. And what this does is this makes a mesh of x's and y's using vectors as my starting point. And the reason I use capital X and Y there and little x and y here is that MATLAB is case sensitive. Capital X and little x are different variables. Now little x and little y are meshes, 401 by 401, and I don't need. Okay, now that I've got my mesh defined, let's define my three functions. I'm going to define z1 as x plus y plus 1. z2 equals x Okay, there's my three functions. The command that makes a 3D plot is a surface command. It's called surf, S-U-R-F. So let's go ahead and do this. Let's go ahead and make the surface plot. That doesn't look very good. What's going on? Well, the thing that's going on is that this is a mesh, and you can see when I make it bigger you can kind of see colors, but it looks like there's some kind of mesh or something over that. Well, there is. Look at that. When I zoom in farther and farther and farther, you can actually see the mesh. Well, I don't want to be able to see the mesh. I just want to be able to see the colors. So let's just zoom all the way back out, and I'm going to go ahead and highlight this. Double click, and right there, see where it says edge color? That's the edge of the little boxes in the mesh. It's using black lines. Well, I don't want a mesh. I don't want to see the mesh. So there it is. Now, one other thing. This is called a color map. It's how it maps z values to a color. I don't really like that one very well, so I'm going to use one called jet, which is a lot brighter. I think might show up better on the screen even. So there's color map jet. That's what it looks like. So there's the first one. Now, I want to put another surface on that plot. So I'm going to say hold on. That says hold. I'm going to put some more stuff on this plot. And let's see what happens now. Okay, same thing. I've got that mesh there. So let's turn that mesh off again. There's a way to turn the mesh off actually in one of these commands, but for right now I'll just deal with it here manually. So there's surface number 3. And there they all are, and I'll turn the mesh off. Now there's a lot going on here, and it's kind of hard to see what I'm looking at. Let's make these other two meshes something different. Rather than letting it choose a color map, I'm going to go ahead and make this just like light gray. You can kind of see there's something going on there, but it's still kind of hard to look at. Let's go ahead and make this sign another color. And I don't know, what does dark gray do for us? Darker gray? Sure, let's do that. Let's see if that helps. Turn that off. And I'm going to go, there it is over there. Oh, look, looking from the top. Now I can see what's going on here. I've got the colored curve, and that's the parabolic one. That's the x squared plus y squared. The light gray one is the plane, and the dark gray one is the sine wave. You can kind of see it there. And where those three intersect, one point there and one point right there, that's the solution. If you want to look at it from the other side, from the back, you can kind of see, oops, see if I can do this here. There we go. One solution is right there, and one solution is right there. That's where all three of the curves intersect. All right, so now we know what it looks like. I'm going to clear all this stuff out because we don't need it any. Whoops. There we go. Clear it out. Don't need that stuff anymore. Let's go ahead and write this out as an anonymous function. And I'll speed this up so you don't have to sit there and suffer while I type. Okay, there, after initially missing one parenthesis, I got it right. So I've got all three of them in there. Now to run Fsolve, all I've got to do is give it the name of the anonymous function, which I've called fn, and a vector of 1, 1, 1. I don't know what the right answer is. Maybe it's close to that. And there we go. There's one of those solutions. And by changing the initial guess, I can find the other solution for you. So there it is. We started with two systems of nonlinear equations, wrote them out, turned them into the right format for Matlab, for Fsolve, plotted the answers to figure out where they were, and have now solved them both using Fsolve. I hope that helps, and we'll talk to you next time.